Hello everyone. So in my previous video I showed the proof of the power rule using first principles. And in this video I will be showing the derivatives of sine of x and cosine of x using first principles. So a few limit identities that we need to know for these proofs to work are the limit as h tends to 0, or I'll just do limit as a tends to 0 of sine of a over a is 1. In some of my other episodes I'm going to show where these come from, so there's like different ways I can prove this, but most of the most useful one that I think is using Taylor series and Maclaurin series for sine of a, or for sine of x and cosine of x, and then the same one for the limit as a tends to 0 for cosine of a minus 1 over a is 0. And those are just the two limits that we need to know for these to work. So for sine of x, we'll let f of x be sine of x. And then we'll just use our derivative formula. So f dash of x, the limit as h tends to 0 of sine of x plus h minus the sine of x divided by h. And what we can do here is, because we have, this is a compound angle, so we can use the compound angle formula. So the limit as h tends to 0 will be, so for the compound angle formula for sine of a plus b is sine of x cosine of h plus cosine of x sine of h. And then it'll be minus sine x, and that's all divided by 0. Or, not 0, sorry. H. Divided by h. Now, what I'm going to do is I'm going to rearrange this. So I'm going to bring this sine of x here, over here, and then that'll allow me to factor out a sine of x, and then it'll be more clear as to where these identities come from and how they help show the derivative of sine x. So the limit is h tends to 0, so I'm going to bring the sine x over, so it'll be sine x cosine h minus sine x plus cosine h, or cosine x sine h, sorry, all divided by h. Now here what I'm going to do is I'm going to split these up into two different fractions, where I've got sine x cosine h minus sine x over h, and then add cosine x sine h over h. So then this will then be the limit as h tends to 0 of sine x. So I'm going to factor out a sine x first. Sine x upon cosine of h minus 1, and then that's all being divided by h. And then it'll be cosine of x sine of h divided by h. Now, what I can see here is sine of x being multiplied by one of our identities. So the cosine of a minus 1 over a is 0. So that becomes the limit as h tends to 0 for sine x upon cosine of h minus 1 over h, plus, now the limit of a sum is also the sum of its limits, so we can bring this limit over here. The limit as h tends to 0 for cosine of x. Equally, you could bring this cosine x here, because it doesn't have anything to actually do with a h, doesn't involve a h, so you could just bring it out, but I might just keep it here, just because, why not? Sine of h over h. Now what we're just going to do is we're just going to use the limits that we know, or identities from here. So let me just highlight these. So for the first one here, sine of a over a is 1. We can see here we've got sine of h over h as h tends to 0. So that's just going to become 1. And then this one here, the limit is a tends to 0 for cosine of a minus 1 over a. Well, that's just this one here. So we can just plug them in. We can allow h to be 0, or h to approach 0, sorry. So this will then become, sorry, no limits anymore. It'll be sine of x times by 0 plus cosine of x times by 1. And the sine of x times 0 becomes 0, and we just get cosine of x. So therefore, the derivative of a function of sine x is cosine of x. Therefore, f dash x equals cosine x. Now, another useful one to know would also be the cosine, because they're very closely related. So I'll just create a line here and we just expand this up here. So we'll let f of x equal cosine of x. And then once again, we'll just use our limit, or our derivative definition. So it'll be the limit as h tends to 0, cosine of x plus h minus cosine of x all over h. And then we can expand that out using the double angle formula for cosine, which becomes, so limit is h tends to 0. So this will be cosine of x, cosine of h, minus sine of x, sine of h. And this will subtract cosine of x. That's all being divided by h. There we go. Now we're gonna, once again, we're just gonna bring that cosine of x over to the this left hand side. So cosine of x, cosine of h, minus cosine of x, minus sine x, sine h, all divided by h. Oh. There we go, all divided by h. And then what I'm just going to do is I'm going to factor out a cosine of x and then also split it into two different fractions with a denominator of h. So then this will become cosine of x upon cosine of h minus 1. That's all being divided by h. And then this will be subtract sine of x upon sine of h divided by h. And then once again, we're just using the limit identities that we established there. Now, obviously, we're just assuming these limits to be true. I would like to, in a later video, to show where they come from, because it's actually quite useful. I think like Maclaurin series and Taylor series are just one of the most useful things that have come out of mathematics, I think. But I like to show you where they come from. Obviously, we're just taking them to be true now, but like I can assure you they are. So we'll just use the limits that we established. So that'll be cosine of x as h tends to 0, cosine of h minus 1 over h becomes 0. And then minus sine of x, the sine of h over h as h tends to 0 just becomes 1. And then we just get that the derivative is minus sine of x. Therefore, f dash of x is minus sine of x. And that's where the derivative for sine of x and cosine of x come from using first principles. So I hope you learned something new. Thanks for watching.